Hi, in this video we will understand one of the LeetCode question which is related to permutation of array or the string. Okay, so let's understand what is the meaning of this question and what this question is asking. Okay, so the question says we are given an integer array. Okay, and all the elements in the integer are distinct. Okay, and we have to give as the output all the permutation, all the possible permutation which can be formed by that integer array. Okay, so permutation, as you know, it means simply arrangement. Okay, arrangement of your data or arrangement of your characters in a given array. Okay, so let's take an example. For example, you are given an array and it has only two elements, 1 and 2. Okay, so these are the two elements of the array. So what can be the different arrangement of these two digits 1 and 2? So we can like have first arrangement is simple. We can like 1 2. Okay, and second is we can just arrange them in like 2 comma 1. Okay, so this is like two ways in which we can arrange these arrange these integer numbers. Okay, 1 2 and 2 1. So we have two possible permutation for this input array. Okay, again let's say we have three numbers. Okay, 1 2 and 3 in the array. Okay, so how many different permutations or arrangements we can have with these three integer numbers? So by mathematics, you know that we can have n factorial basically permutations. Okay, where n is the total number of integers in this given array. Okay, so it has how many integers? 3. So basically we can have 3 factorial, that is 6 permutations, right? And how we can get them? So simply we can say, okay, we have to arrange the three numbers 1 2 and 3. Okay, in different ways. Okay, so we can say here first permutation can be like we can fix 1 here, we can fix 2 here, we can fix 3. Okay, 1 2 3. This is the simple permutation. Another way is like we are keeping 1 as the fix, but here we will make the arrangement of the 2 and 3. Okay, so what can be the different permutation of 2 and 3? First one was 2 and 3. Second is just swap 2 and 3. So we will get 3 2. These are the two permutations we can get if we can keep 1 as the first position. Now if at the first position we are keeping 2, okay, then here what can come? We can place either 1 and 3 or 3 and 1, right? So if I keep 1 and 3 here, then this is the third permutation. Another will be 3 and 2 is 6. Okay, so this is the permutation by keeping 2 at the first position. Similarly, if we keep 3 at the first position, then here what we can have? We can have 1 and 2. Okay, different ways of arrangement of 1 and 2, 1 and 2 and 2 and 1, right? So 3 is fixed. So this is the next permutation. So 2 2 2, total 6 permutations, right? I hope you know how we can get the permutation by simply arranging the element. Okay, this is just simple mathematics. So the question is, if we are given this integer array, we should be able to return all these possible 6 permutations, and these are the different possible permutations. Okay, we can return in any order. We can print or like first this, then this, then this. Okay, it doesn't mean that you have to return the answer in some particular order. You can return this arrangement in any order. Okay, now simply let's say we have 0 1. Okay, that is two elements 0 and 1. So we can have one permutation as 0 1. Another can be we can just interchange 1 and 0. So we can have another permutation 0 1 1 0. And if we are given only one number in the array, then we can have simply only one permutation. Okay, so let's understand how we can print all the permutations. Okay, so let's say you have only two numbers in the array. Okay, 1 and 2. Okay, and you can have array like 2 comma 1 also as the input array. Okay, it doesn't mean that you will be given a sorted array. Okay, the question is not saying this. Okay, you can have any type of array, unsorted or sorted. Okay, now let's say you have only two numbers 1 and 2 in the input array, and you have to print the permutation, and you know that there can be like two permutation only for 1 and 2. Okay, so how we can do that? So basically what we can do is like we can say, okay, first permutation can be like we can put 1 as the first position. There are two positions, right? 1 at the first position. Now here we are left only with 2, so 2 can come. Now the another way or another arrangement can be at first position we can keep 2. Okay, we can keep 2, that is we are fixing 2. Now here we are left with the remaining element, and remaining element is the 1, so we can keep 1. Okay, so after that there can be no other element that can come at the first position, right? Because only 1 and 2 are there. So these are the possible two permutations. Okay. Now let's take another example. Okay. Let's say we have 1, 2, and 3. Right. So these are the three numbers in your input array. So how we can like go and how we can build the logic basically. So let's understand with this input array of 1, 2, 3. That is three numbers. Now what we will do is, as we were fixing the element at each position, okay, so this logic we will like try to implement. Okay, so what we will do, first we will say at first position, okay, or you can say 0th position. Okay, I'll say at first position. Okay, at first position how many element can come? See, 1 can come. Okay, at this position 2 can also come. We can get another type of arrangement by fixing 3 or by putting 3 at the first position. Okay, so basically there can be, you can say, three different directions, or there are three different possible ways to fix the element at the first position, right? So three directions. Okay, so let's understand. Okay, with the help of tree. Okay, I will build a tree. Okay, so basically I will say, okay, at the this first position fix 1. Okay, you fix 1. So I will say 1 is fixed at the first position, and now other elements are like as such. Now 1 is fixed. Now next again I will, like you can say, go again, and I will say at the second position. Okay, because we are left with this element now. Okay, so at the second element what can come? I will say 2 can also come or 3 can also come. So I can have two directions, okay, to fix the element at this position, okay, at this second position. So I will say 1 will remain as such, but here I am fixing the element. Okay, so either 2 can come, okay, or here 3 can also come, right? So this way we will go. Okay, so let's move with this direction. So here 2 is fixed. Okay, so basically what I will do, I will tell you later. Okay, in the like when I will tell you the code, that I am actually swapping. Okay, swapping means interchanging. I am actually swapping 2 with 2. Okay, and now 2 is fixed. Okay, 3 will be there. Now I have fixed this position also, this position also. Okay, that is here 1 is fixed, here 2 is fixed. Now we are left with the last element. Okay, now here only 3 can come. Okay, so there is only one possibility. So what I can do is I can just stop here. Okay, because there is only 3 element. Okay, and this can swap with itself only. Okay, even if I do not swap it, okay, I will get this, okay, output array. Okay, so 1, 2, 3. So I will stop here simply, and now this is my first permutation, 1, 2, 3, by fixing 1 at the first position, by fixing 2 at the second position. Okay, and 3 is by default fixed at the third position. Now I will go again and I will come this direction. Now here, as I told you previously, what I can do is, here 1 was fixed. Okay, now as we are concentrating on this part, okay, that at second position what can come. So in this direction 2 was coming. Okay, we said I am fixing 2. Now here 1 we are not touching. Okay, so here now I will say what I can do, I can fix 3. Okay, and how? See, 2 and 3 was there. First I fixed 2. Now here I will say I can fix 3. That means I will interchange, I will swap this 3 with this 2. Okay, so if I swap 3 and 2, so here 3 will come, here 2. So in this way 3 has come here. Okay, now 3 is fixed. Now I am left with the last element. Okay, so last element will by default be fixed. Okay, so I will not touch this and I will not go down. Okay, now this is my second permutation. Okay, so this is my first permutation. Okay, and this is my next permutation. Okay, and here we can say, we can simply print 1, 3, 2. We can print this array. Okay, now we will go again. Okay, and now here we have arranged all these 2 and 3. Okay, now we will go here. Okay, now this label is actually telling that at first position, at this position what can come. Okay, so first I decide in this direction 1 can come. Now in this direction I will say 2 can come. Okay, 2 can be fixed. Okay, so what I will do is, I am saying, okay, 2 can come at this position. So I am actually swapping 1 and 2. Okay, I am saying it 2, please come at the first position. Okay, so this is the another way. Okay, so I can fix 2 at the first position. Okay, and 1 will come here. Okay, please untouched. So now here 2 is fixed. Okay, now I will concentrate on this. Okay, same thing I will apply here. Now 2 direction will go. Okay, so again 3 positions. Okay, so how we can arrange this 1 and 3? So I can say at this position, okay, what can come? Okay, because this is saying okay at this position, okay, that is at this position, what can be the possible candidate? Okay, so one is I am swapping 1 with 1, that is I am fixing 1 here. Okay, so 3 will remain here. Okay, and 2 is as such before. Okay, so this is one permutation. Now we are left with the last element. Okay, now we will not go down because it is by default, okay, at the third position and it will be fixed here. Okay, now I can get the third permutation. I will go again, and now the another way, okay, to fix the element at this position is we can keep 3 here. Okay, that means I will swap 3 with this one. Okay, so at second position 3 can come, that is 1 and 3 are swapped, so 3 and 1 are swapped, and here 2 is attached as such. Now second element is fixed. Now for third element I will not go down because there is only one element. Okay, so either you swap it with it and then you return, or you do not swap. Okay, you just print. So fourth. Now we'll go again here, then again here. Okay, now here in this direction 1 was fixed, in this direction 2 came at this position. Now in this direction, okay, we will say now 3 can also come here. Okay, we can keep 3. Okay, so basically in this direction I will say 3 and 1 are swapped and 2 is S. Okay, so before going further, you can see that in this direction, okay, we got all the permutation which are starting from 1. By keeping 1 as the first position fixed, we have got all the different permutation. Here, okay, that means in this direction we got all the permutation which are starting from 2. Now in this direction we will get all the permutation, different permutation which we can get after fixing the 3 at the first position. Okay, so again 2 direction will go because now we have to see, okay, the arrangement here. Okay, because 3 is fixed. Now at second position what can come? So one way is we can fix 2 itself. Okay, so 3 will be S well. So 2 is fixed. Now again last element will not do anything. So we are done. This is the fifth permutation. Now for this permutation, let's see here. So now at this position, what can the element that can come? So here 2 was fixed in this way. Now if we swap 1 and 2, so 1 will come here, 2 will go here. So this is the another permutation that we can get by arranging these 2 elements 2, 1, right? And 3 is already there. Okay, 3, 1, 2. Now we are left with last element, so we will not do anything. Okay, because it is by default at the fixed position. Okay, so this is the sixth permutation, right? We got all the 2 permutation by keeping 3 at the first position. Okay, total 6 permutation we got. Now we will return and then we will return. Okay, now after this like we are at the end of the array, so we will simply return to the main function. Okay, so this way we got all the different permutations. Okay, I hope you have got. Okay, so we are actually taking the help of the swap operation and then we are permute. Okay, so let's take another example and then you will be very clear. Okay, let's take a bigger example 1, 2, 3, 4. Okay, so this is our bigger example 1, 2, 3, 4. Okay, so there are 4 different integers. So 4 different integers. So that means 4 factorials. Okay, 4 factorial, that is 24. Okay, that is 4 into 3 into 2 into 1. These many number of permutations or arrangements we can get by these 4 distinct integers by arranging them. Okay, that means first is like 1, 2, 3, 4. Okay, second is like we will keep 1 fixed. Okay, 2 fixed, and then we can permute this 3 and 4. That is second. Okay, then again 1 is fixed. Okay, so we are actually permuting 2, 3, 4. Okay, so 1 was like 2 fixed and 4, 3. Now here again the another number that can come is like 3. Then we are left with 2 and 4. So one will be 2 and 4, another will be 4, 2. So 1 was 6, 3 was 6. Same way, 1 is fixed. Now here what can come? 2 has come, 3 has come, so 4 has come. Now we are left with 2, 3. And another will be 3 2 1 4 3 2. So this way, this is one set of permutation by keeping, you can say, 1 as fixed, okay, at the first position, okay, 1 2 3 4 5 6. So same way we can have 6, okay, same way we can have different permutation by keeping 2 fixed here, okay, that means 2 and then filling these positions, okay. Again we will have 6 permutation, then we will fix 3 at the first position, and we can have total another 6 permutation. Same way 4 is fixed at the first position, and then again doing the same thing on here, and total 6 permutation we will get by fixing 4 at the first position. So total 6 4 are 24 permutations, okay. So this you know with the help of mathematics, okay. Now the same analogy I'll apply again here, okay. So at this level we are trying to fix, okay, what can come at the first position. We are fixing the element at its first position, we are trying to fix, okay. So here we will have 4 different directions. Why? Because at this position 4 different candidates can come. Either 1 can come, either 2 can be fixed, either 3 can be fixed, or either 4 can be fixed. So here we will be fixing 1, here we will be fixing 2. In this direction we will try to fix 3 at the first position, and here we will try to fix 4 at the first position, okay. So in this direction I will get all the different permutation by fixing 1 at the first position, okay. So how I am fixing? So basically I am fixing 1 with the 1, okay. So that is I am swapping 1 with the 1. So what I will get? I will get 1 itself, okay, and 2 3 4 are as such. So I have fixed 1. Now we are left with these 3. So again I will go, okay, and again you can tell me that how many different directions I will draw here. So basically we are left with 3 elements, okay. So 3 different directions. Why? Because at this position, okay, now we want to fix what can come, okay. So 2 can come, 3 can come, 4 can come, okay. So basically in this direction I will fix 2, okay, at the second position. How? I will swap 2 with the 2. So 4 position, 2 with the 2, I'll get 2, okay, and 1 is as such, 3 4 will be as such, okay. Now we are left with this, okay, 1 and 2 are fixed. Now we have to see 3 and 4. So 2 direction will come. Why? Because at this position either 3 can come, either 4 can come, okay. So 1 2 will as such. Now I will swap 3 with 3, 3 with 3. Here I swap 2 with 2. So 3 with 3 swap, 3 will be there and 4 will be as such. So here 3 is fixed. Now we are left with last element, so we will not do anything, okay. So this is my first permutation. Basically if you see, okay, here I'm trying to like make the arrangement in 3 elements. If I go one level down, I have fixed 1 element, I am left with the remaining 2 elements. If I go one level down, I am left with the 1 element, and after that I will stop. The same thing I will do here. I will return now and I will say, okay, here I have fixed 3. Now the another candidate can come, here is 4. That means I am swapping 4 with the 3, okay. So 1 and 2 as such is fixed. Here 4 can come, 3 will be. So 4 is fixed here in this direction. Now we are left with the last element, but last element will by default be at the fixed position, correct position, okay. So this is the second permutation, okay. So in the same way we will go again, we will go here, okay, and here I will say, okay, what can come? I will say now 3 can come. So here what I will do, I will swap 2 and 3, right, and I will proceed further, okay. Then I'll get like 2 different permutations, okay. Then I will go and I will go here. What I will do, what 2 things I will swap which can like help me to get the element at this position. So here 3 has taken the place. Now 4 will come. So I will swap 4 with the 2. So 2 and 4 will be swapped, okay. Then one level will come and again I will go again, okay. So this way I will get another 2 permutations, okay. So in this way, if you see, by fixing each element, okay, I am doing the same procedure on the remaining element, okay, and I am going in this direction, okay, 1 then 2 then 3 then 4, okay. So basically I am using swap operation, and then again I am recurring. Let's say we have a function permute, okay. So let's say we have a permute function, okay, which is taking a array, okay, or let's say its size, okay, something, and it is doing swapping and permutations, okay, again and again, okay. And there will be some base condition, okay, which will be stopping me, okay, to print this given array, okay. Otherwise I will do this thing, okay. Now let's see how we can actually do this, okay. So this is my previous example 1, 2, 3. Okay, and this is our code. Okay, that we will understand that how it is related and how it is helping us to achieve our output. So if you see, this is my first level. Okay, this is my second level, and this is my last level, third level. Okay, so at the third level I am printing all the answers. Okay, at the first level, okay, there are three directions that are going. Okay, because we can fix here in three different ways. First position we can fix three different ways. I can put 1, I can put 2, or I can put 3 at the first position. Now if you go down, okay, then the number of directions, they are decreasing. Okay, here only 2 directions are there. Okay, and at the last level we are not proceeding further. Okay, so the number of, you can say, as the number of levels are increasing, our directions are decreasing. Okay, and we are achieving the output. So basically, if you see here in this direction, I have swapped 1 with 1. Okay, and here 1 is fixed. Okay, basically here I have applied swap 1, 1. Then here I am left with 2, 3, and I am trying to fix what can come at this position. So I say swap 2 with 2 is one way, and another way is swap this 3. Okay, 3 can come. I am swapping 3, 2. Okay, 2, 3 are swapped, so 3 can come. Okay, so this way I got 2. So here also I apply the swap. I am writing just S. Okay, swap. Okay, and here also I swap. Okay, 2, 3 swap 2, 3. Right, the same way I am doing here. Okay, here I am saying okay, at the first position 2 can come, so I am swapping 2. Okay, so 1 and 2 are swapped, so 2 can come and 2 is fixed. Now I am applying the same permute operation. Okay, recursive operation for these 1 and 3. I am trying to fix here. Okay, so one way is just swap 1 with 1, so I have swapped 1 with 1. Another is swap 3 and 1, so that 3 can come. Okay, 3 can come. So again swap operation, S operation, S operation. Again I am going here, and now in this direction I am saying 3 can come here. So 3 and 1 are swapped. So I got 3 here, 1 here, and 2. So 3 is fixed. Okay, and now I am trying to fix here at the second position. Okay, so one way is swap 2 with 2, and another way is swap 1 with 2. Swap 1 with 2. Okay, so the second position is fixed, and at the last position we are not doing anything. Okay, so here this is the swap operation and this is the permute operation that I was telling. Okay, so now let's understand this code. So there is a permute function, okay, which is called, let's say, from the main function, and we are given this integer array, okay, in which 1, 2, 3 is there, and I have actually taken 2 other parameters. What are these parameters? So position is basically initially 0. Okay, 0 means that is this position. Okay, and end is the, you can say, last position. Okay, so this is the 0. Okay, this is the 1, and this is the 2. Okay, so 2 will come here. Okay, last index of this array. Okay, so this is given as the input. Okay, so n can help me to know the what is the size of my input array. Okay, simply you can see. So basically what I am trying to do is, here you can see there is a for loop. Okay, now you have to understand this very clearly, that why we are using for loop, and I hope some of you know that why I am using for loop. So basically if you see at this level only, okay, here again and again we are applying this swap operation, swap operation, swap operation, right? And how many times? 3 times, because here either 1 can be fixed, here either 2 can be fixed, or here 3 can be fixed. So 1 can be fixed in this direction, 2 can be fixed, 3. So I am taking a loop, okay, for loop, okay, which is basically starting from I equal to, see, initially this is 0, okay, 0, but I am not writing 0, I am writing position, so you can say simply 0. And if you see just this level, how many times I should iterate? Okay, I should go at 1 so that I can fix 1, then I will go at 2, and then with the help of swap operation, I will swap 2 and 1, then I again come at 3, and then I will swap 3 with 1, then I will swap 3 with 1. Okay, so this loop is going till end. Okay, so end is 2. Okay, so for 0 it will go, for 1 it will go, and for the second position also it will go. Okay, this way. So that's why I'm using a for loop. Okay, I have to do it again and again. And now here I cannot write 0. Why? Because the same loop, if you see, after swapping, I have to go down. That is, I have to permute. After swapping, okay, I have swapped 1. Then I have to go down. Okay, for that, this is the permute function, which is calling again and again to itself. Okay, and then when I will come here, I will somehow come here. So if I write I equal to 0, then it will start from here. And if I see at this level, I am not touching 1. I have to see only 2, 3. Okay, that is, now I have to start from the next direction, one greater position. Okay, that is at this 1th position. So this POS, okay, if you see here, if you see, this second parameter is getting incremented from here. A new value will go here. So a new value will become as the starting position. So for 2, 3, this for loop will start from the 1th position till last. Okay, if I put 0 here, then it will start from here, and again it will like somehow do the same thing. Okay, position is 0, I is 0, so again it will swap 1 with 1. So I will not achieve anything. Okay, so I have go like ahead. Okay, so that's why I am incrementing here and I am taking that thing. Okay, now let's understand this code, okay, in a better way. So basically this is our permute function. Okay, and now this is our base condition. Okay, and here we have used the recursion. Okay, we are recursively calling this permute function. Now basically in every you can say iteration of this for loop, what we are doing. Okay, so basically initially this is 0 and this is 2. Okay, for this example 1, 2, 3. So I will come here and I will say this POS. Okay, so this POS is the position that we want to basically fix. Okay, basically the position that we want to fix will be pointed out by POS. Okay, this position variable. Okay, now what I am doing is here I want to fix 1. Okay, so that means I swapped 1 with 1. Okay, so I will come here. Okay, and I will start from I equal to 0 till 2. Okay, so this is 0, this is 1, this is 2. Now for the 0th position, I will say swap this 0th position element, okay, a of 0 with 0 itself. Okay, so currently this is my POS and this is the same variable I is also pointing here. So POS and I, they are swapped. So 1 is swapped with 1. Okay, I got this. Now after that I am saying permute. Okay, that means I have come here. Okay, I have 1 with 1 and then I have permute. So permute. Now array is changed. You have to take care of this. Okay, we are actually changing the elements of the array. Okay, this swap will change the element of the array. Okay, so one is actually you can say, although this is looking similar, but here you will see the difference. Okay, when you will see that the array is changing from 1 2 3 to 2 1 3. Okay, now again permute will come here. Now basically as first position is fixed, or you can say 0th position is fixed, now we have to concentrate on the next position, that is this position. Starting position should be this. So we are actually incrementing our position variable. We are saying now position will be pointing to the next position, that means here. Okay, POS, and now this POS will get 1 here. Again 1 is not equal to end. Okay, 1 is not equal to end position, so we'll come here. Now we will iterate the loop from this first position to the last position. So again this loop is starting. So this loop will start from 1 to 2. Okay, now we will come here. Now I will say, okay, swap a of position, okay, with a of I. So currently I is also 1, position is also 1. That means position and I are same. So both, that is this element will be swapped with itself. Okay, A1 and A1. Okay, swap. Now again by this swap our second position is fixed. We will go down, that is we will permute. So here if you see, again we are incrementing the position. Position is currently 0 1 2 1. Okay, position is currently 1. So 1 plus 1 2. So now 2 will go. Okay, and end is same. Okay, we are not changing end. So now we have come here. Okay, now we will say, okay, this 2 and 2. Okay, position is 2, end is 2. Okay, we have come here. So position is here. Okay, or end is also here, same. Because both are same, we are just saying simply print the array, because we are not saying okay, because we are not moving further. The third element will always be at the correct position. Okay, we are printing the array, so we can just print the array. We can call a function and we can use for loop to print the array from I equal to 0 to I less than equal to end. Okay, and we can simply print the array. Okay? 1 2 3. Now after this we'll again go here, okay, and now we'll come at the same position, and basically we have come here, okay. Basically this is actually helping us to find the combinations, okay. This is helping us to recursively go. Now if we go, if we come again, this line is important. This line is helping us to backtrack, okay. Backtrack means, as I have told you, that this array will actually get changed, okay. Although here it is not getting changed, but eventually you will see, okay. I will tell you later, okay. This swap is needed, okay, but let's see it later, okay. Now I will come here, okay, and now I will iterate, or I will increment I plus plus. Now I will be at the second position, okay. So this I will be at the second position, okay. The position is same, position variable is same, that is 1, but I will be 2. So this is position and this is I. So now here position is 1 and I is 2. So 1 and 2 element are swapped. That is 1 is position element and second position element are swapped. 2 is swapped with 3. So 2 and 3 are swapped. Okay. So I will get 1, 3, 2. Okay. And then I permute. Okay. Now position is basically here, and here when I will come, I will increment position. Okay. So position is 1 plus 1, 2. So 2 will go. 2 will go, okay. So here I have come, position is basically 2 and end will always remain as 2, okay. Now position and end are same, okay. That means the element or the position that I want to fix is this, that is end position. That means we are okay, we can just print the array, we will print the array, okay. Then again we will come back, okay. Now if you see, I was saying there is only one array, basically 1, 2, 3, okay, and the same array has got changed to 1, 3, 2, okay. The element are changed. We cannot go with this change 1, 3, 2. We want to get back from 1, 3, 2 to 1, 2, 3. So what we will do? We will undo the swap operation. So basically the same operation, position and I, that we did here, we are actually again doing, okay. So this position 1 and 2, okay, that is this 1 and 2, they will be swapped and we'll get 1, 2, 3 again, okay. So that same changes we get again, okay. If you do not write this, okay, you'll get wrong answers. Then we will come here, okay, we are done with all the iteration of the loop, so we will again go back, and now here position and I was at the first position. Now what we will do is again I plus plus will happen, or I will come here, okay. Now again I has come at the position at 0 and I has incremented, so I has become 1, okay. So now again position 0 and I 1, they will be set, 2 and 1 will be set, okay. So 2 and 1 will be set, okay. So this way this all complete loop will go, okay. When this all iteration will be completed, then I will be coming at this, and this I and this position will be set, okay. That is, we are fixing this position. How? We are picking the ith element and we are putting at the first position, or at the position which is pointing by POS variable, okay. So this is our complete code, okay. So let's see into our IDE also, and before this let me tell you what is the time complexity of this whole algorithm. So time complexity will be order of time to print the array, okay, or you can say one permutation, time to print one permutation, okay, one permutation into total number of permutations, okay. So here you can see for 3 we are getting 3 factorial permutation. So for array of size n, we will get n factorial permutation. So this number of permutation will be n factorial. Now time to print the one permutation, okay. So if you see here, we are printing the one permutation. So you can understand in this way that they are like n elements, okay. So we will get n time, okay, to print these all 3 elements, okay, n. Or you can understand in this way, okay. So to print this answer, okay, from this position we are going down how many levels? 1 level, 2 level, and at the 3rd level we are actually printing, okay. So we have to do this much of effort, okay, to print this permutation, okay. So n time, okay, n time will take, okay. So basically it will be total of n into n factorial time complexity. And what will be the space complexity? Okay, we have taken the stack, okay, because it is using the recursion, okay. And if you see how many levels are there? You can say for 3, there are 3 levels. For n, there will be n levels. Okay, so the stack size will be equal to n levels. Okay, so the space complexity will be order of n. Okay, this is actually taken by the stack. Okay, and if you are not counting it, then it is constant space complexity. Okay, so now let's see the code. So here is our code. So this is a permute function. Okay, and here you can see in this permute function we are given a vector as the input. Okay, not the array. Okay, and we have to return the vector of vectors. Okay, we have to put all the permutations in this vector. Okay, and then we have to return, as you can see here. Okay, so we have taken our final answer name vector of vector. Now we have calculated the vector size. Okay, and here we have passed them. Okay, so nums is our vector. Okay, 0 is the, you can say, starting position. Okay, and -1, that is the last index, okay, of our array, and this is our vector of vector that we want to fill. Okay, and finally we are returning that filled vector of vector. So if you see our permute util function, that is the helper function here. Okay, so this is our vector a, this is the position, this is the n, and this is our answer, final answer, in which we want to put all the arrangements or the permutation. So if position is equal to n, but we are doing the vector, okay, or you can say the arrangement, okay, that we have got, we are actually filling it inside the file answer. We are pushing it there. Okay, and then we are returning. Okay, we are not printing directly here. Okay, otherwise we are doing the same thing. Okay, we are iterating this loop. Okay, so this is very simple code. Okay, I'll provide the link of this code in the video description below, so you can check there. Okay, so if I run this, okay, we are getting the correct answer. This is accepted. So these are some of the related questions with the permutation. You can have a look on this and you can practice them. I'll make videos on this in the future. Okay, so if you have any question, comment, suggestion, please write down into the comment box, and please let me know how you like this video. If you have any question, please also write in the comment box. So see you in the next video. Till then, goodbye.